Okay, I was given this question recently, and I think it's a very tricky question, especially because of this domain. Now, I will give you a hint. You could pause the video if you want and try and work it out, and I'll give you a hint. There are actually 4 answers to this question. So I've got 4 different values of x for this question, and I'm going to do it without a calculator. So first of all, what I want to do is think about this √3 and this angle. So I'm going to draw a triangle. I'm just going to let's draw the triangle here. And if I think about I'm going to draw it with the quadrants. I want to think about this triangle with the √3, which means that opposite the angle is 3 and adjacent is 1, opposite over adjacent. So I've got this sort of triangle here. And I know now that this one here is √3 and this one here is 1. I actually know this is 2, and I know that when I've got a triangle like this, that the angle in here is pi over 3. So I know that this angle equals pi over 3 simply from my knowledge of this triangle. So I'm going to start off by getting rid of the tans, and I can just say that x plus pi over 6 can equal pi over 3. Very straightforward. However, that's if I measure clockwise and have a positive angle. I can also, because it says √3, I could also look at it where the √3 is negative. So I can go into this quadrant here. So I'm just going to repeat this triangle, but in this quadrant here with √3 and this time -1. So it gives me, this will also give me a triangle where I've got pi, this angle here going positive is 2 pi over 3 because this angle is still pi over 3. So I've also got another set of solutions, which is x plus pi over 6 is equal to 2 pi over 3. I've got another one which comes in this quadrant here, which is equivalent of going 4 pi around. Now I've actually tried that one, and I've actually found that none of those, sorry, I beg your pardon, it will work. It's going to be x plus, and I'm going to go all the way around to this section here, which gives me 4 pi over 6. So that's in the third quadrant. Sorry, 4 pi over 3. And there's one in the fourth quadrant with the negative answer, which is x plus pi over 6 is equal to 5 pi over 3. And actually, I'm not going to use this one, and I'll explain why in a minute. But there are more. This is doing the positive angle. If I do a negative angle, I come down here, negative pi over 3. So I have another one, which is x plus pi over 6, and it gives me a negative angle because I'm going the other way. I'm going clockwise. And if I go negative, and it gives me the negative 2/3 by coming around like this. Now, I actually could add 2 pi onto all of these as well, but I've actually checked them and I want to keep this video shorter. It won't actually work. Now, if I just take this first one here, I am going to get x is equal to pi over 3, which I'm going to call 2 pi over 6, take away pi over 6. I'm taking that from both sides. This gives me pi over 6. Let's just circle that because I definitely want that as one of my answers. It fits the domain. This one, 4 pi over 6, take away pi over 6, equals 3 pi over 6, which is pi over 2. Fits my domain, so I'll circle that one. This one is 4 pi over 3. So actually when I do this one, it's 4 pi over 3 take away pi over 6. Let's make this 8 over 6. It's going to give me 7 pi over 3, 7 pi over 6, which is outside my domain. And likewise, this one's outside my domain. So I don't want anything here or here because the answers won't fit this. So I've got these two answers so far. And this one becomes minus pi over 3, which I'm going to turn into minus 2 pi over 6. Take away pi over 6 gives me negative pi over 2. You can just check that one. And you can see I'm running out of space here. And this one, which is negative 4 pi over 6, take away pi over 6. And this gives me negative 5 pi over 6. So I actually have all these answers as pi over 6, pi over 2, minus pi over 6, nice bit of symmetry to it, and minus pi over 2 from here. And I have checked out various other answers, but those are the only 4 answers that work. So I like this question. I think it's quite a neat question that you would get at the end of section A to do.